So database management system 1, under the lesson 2, lecture 2, we have to discuss the historical perspective of the database. So here this week 2 we have to discuss the second lecture, and outline of the today's lecture. First of all, I will explain how to evolve the databases, evolution of the databases, and historical perspectives of the databases, and type of the databases and applications, file-based processing, and advantages of using databases. Especially, I am going to discuss these 5 subtopics in today's lecture. So, the evolution of the database modeling techniques, when you see this picture, you can understand the data. It will start in pre 1950s, beginning of the 1950s. The database, the data must store the data in a certain place is needed. For that, the 50s, 60s, 70s, 80s, and currently we are using different types of databases according to the data. Some of them are used for store the structured data, and some of the databases are used to store the unstructured data. That is, there is no any type. So then when you consider these modeling techniques, first of all, it was introduced the file systems. Then it was used from 1950s to 1970s. The file systems, all the data had been installed in files. So when the file system was using, there were some difficulties to handle the data in the files. So to overcome such difficulties, actually the 50s also once again introduced the hierarchical data modeling techniques. We'll explain later. And 1960s introduced the network, and 1970s introduced the one of the most important, and still this method is heavily used, the relational database model. The relational database model is the one of the most famous model even now, and that was introduced in 1970s in the Bell. I remember the Bell IBM. Then 1980s, with the introduction of the object-oriented programming language. As you know, I think you may not know still because you didn't study the object-oriented concepts, programming concepts, and object-oriented. When you study the object-oriented concepts, you can understand the first object-oriented programming language is not the Java. Before that, there was a language that is called the Smalltalk. That was introduced in early 70s. Smalltalk was not so famous like other object-oriented programming language, and with the development of that programming language, it was introduced the object-oriented databases. But there are some limitations of the object-oriented. Still, the object-oriented databases are used, but those databases cannot be extended very easily so that when you want to add a certain field or delete a certain field from the database, so it will the program also must be changed. So there may have some difficulties comparing to the relational data model. So and also then combining the relational modeling techniques and object-oriented database techniques, it was introduced the object relational databases in 1990s. Object relational databases. Now there are some different companies introduce the database systems. The IBM as well as Microsoft also, and Oracle. Likewise, you can find the Oracle database systems and other types of the SQL, and MySQL is the open source. You can get the license version of the SQL structured MySQL. Most of the applications are used MySQL databases because those MySQL is open source. But there are some limitations. That limitation is not influence for the database management system. That means if the company wants to store the more than 5 giga of data, so there may have a certain problems of the but most of the companies use the MySQL with the when they develop the database management systems. So then we'll go to the next slide, and if we understand the file system, flat files since 50s, we can find this flat file, separate file each with a tabular organization. For an example, payroll system has the payroll master file and transaction file, and using that file could be prepared the paycheck and stub, payroll reports, and new payroll master file. So historically use punch card then or the tape. So when you consider the second and third generations, most of the time those generation computers use the punch card and the paper tapes. The punch card is a certain type of a card. The data could be stored by punching on it or the tape. Then I don't know whether you have seen the magnetic discs, the 3.5 diskette and 5/4 diskettes. And when we were in the university, we used those magnetic discs. But you can store a certain limitation, not like the DVD or CD. Small amount of data could be stored in the magnetic discs also. Then normally use the batch processing when it is needed. Then when it was needed, use the batch processing and no interaction. Another one is multiple users cannot be used simultaneously. So one user at a time can only be used. Today, CSV files, comma separated versions or values, text files, spreadsheet files can be given as example, and data mining. So as the batch processing, updating and deleting of the data is little bit difficult in this flat file systems. And next, introduce the here data model. Once again I can explain hierarchical, network, relational, object oriented, and object relational. The difficult to represent in the hierarchical model, The next model is hierarchical model. When we see hierarchical model, then in the hierarchical model, difficult to represent M to N relationships. You know that when you get the relational model, you can find one-to-one relationship, one-to-many relationship, M to N, many-to-many relationships. I will explain what are the relationships are later on this lecture. Then difficult to represent this M to N relationship, then only we can maintain the parent and child relationship. And network model could handle the more relationship than the hierarchical model, but the relational model provides the maximum to handle every relationship, whether it is one-to-one or one-to-many or many-to-many. Tables simple and easy to understand. Object-oriented databases, actually data will be stored as objects. You know that object is, you may have some confusion what is an object. Consider that a person, when you get a person may have a first name, a surname, date of birth, age, permanent address. Likewise, there are different things. All these characteristics will be stored in an object as objects. Object relational actually combining, as I explained you, combine the relational and object oriented. So then next we'll go to the next lesson, and here is the hierarchical model. Hierarchical model you can see as hierarchy, then can only represent one to n relationship effectively. So one company can have the multiple invoices, and one invoices can pay the multiple payments. Likewise, contacts, letters, faxes, emails, like one to n relationships. And the hierarchical model, normally called the tree organization of the data, since 1960s. Earliest approach of integrated data, actually IBM used this one, and still in use, especially in financial and insurance sector we can find this. Today, return to this approach with XML, extended markup language, text files. You can understand when you are developing the program. XML, extendable markup language, actually text files we have to use. In such case, in that time you can understand this hierarchical data model. Then the network model. Network model, you can see 1 to m relationship like this. So it may have a network, but there are some difficulties. It handles more relationship types such as 1 to n and m to n. The network and link list, directed graph. This is something like the link list or directed graphs. Efficient storage and retrieval. We can this network model is efficient storage and retrieval, and complex design and navigation. So it will be a little bit complex for design and navigation, and developed by CODSIL, Committee on Data System and Languages. This was introduced, the Committee on Data Systems and Languages, with brought as COBOL, Common Business Oriented Language, actually COBOL. This network data model heavily use this COBOL and standardized terminology, layered architecture. It can find the standardized terminologies as well as layered architectures. Today, the network approach is found in object-oriented databases. This network approach can be found in object-oriented OODB, object-oriented databases. And here is the relation. Then gradually introduce the relational module, one of the most important module we have to study in deep in this relational model. That there may have a table, each of which may have a relationship. The relationship can be the 1 to n, 1 to 1, 1 to n, and n to m. The 1 to many, 1 to 1, 1 to many, and many to many relationships. Very easy to understand, very simple, and we can easily create the databases for our applications. Most of the solutions, software solution, use the relational databases. In your course also, I will give some what we call the lab sheets. Even though we don't have the labs, but you have to practice at your home. You have to install the MySQL database and created the table in a given scenario. And relational databases actually primary approach today since late 70s. These actually tables, actually normally called the relations, consist of rows. Normally we call the keyword tuples, and columns means attributes. Table consists of the rows and columns. Rows are called the tuples, columns are called the attributes. Actually, this is very, very important because columns represent the attributes, that is the characteristics. For an example, get the if you want to store the student information in a table, you will have to store the student first name, last name, date of birth, then age, address, telephone numbers, likewise. Those are called attributes. And if you store the information of one student, for an example, you are going to store, because imagine that I am a student, so you want to store my information, my first name Rohan, surname Samarasinghe, date of birth as well as address Kuliyapitiya Kurunagala, then telephone number and faculty study. Likewise, you can write the information. One row related to the information of one person, that is called the tuple. Row has the information of one person, that is called the tuple, and columns are called the attributes. Actually, columns consist of the data fields. So table and attributes are name. Each table has a name as well as each attribute must have a name. And not only the name, but also you have to give the data type of each attribute, each column. For an example, name. What type of data you are going to store? The type is string, and you can define the length also. Char means the character 50, that is maximum up to 50 characters you can store. Or else vacha 50. The char and vacha, variable character and char, has a different. When you define the database giving the giving the data range, for an example, first name char 50. That means when you are going to compile these databases, data table, then it will allocate the 50 to store the 50 bytes of data, whether the name is not in the 50 bytes. For an example, the name to write your surname, it needs only 15 bytes. But you have allocated the 50 byte. That is, another 35 bytes are allocated in whale without any usage. So then, if you go use the varchar variable char, it will allocate according to your name. No any additional space is given allocated. So likewise, you have to think how to do that. Then relationship between the table are established by common values. Relationship between the tables are established in the common values and mathematically based on set theory. You will be able to understand what is set theory in the mathematics lecture. And basically, this is actually mathematical model, the base on the set theory. And also personal computer to mainframe server base also can be used. SQL, structured query language, is the workhorse query language and is often adopted for other programs. So if you want to retrieve the data and if you want to filter the data, you have to use this structured query language to retrieve the data from the databases. So that during this course module, we have to understand this relational model in deep. Then object-oriented database since 80s. So embedded Java, actually Java or C++, you know that the C++, Java, C# are commonly used object-oriented programming languages. So those languages can use the relational data model also and also use the object-oriented databases. So unifies object heap space in memory and secondary storages and return to the network approach and influence relational model to object relationals. As I told you, in this object-oriented databases may have some limitations and it can only be used the object-oriented languages. No other languages cannot be used. But relational databases you can use whether the object sequential languages like C and other, the object-oriented languages as well as the PHP, and especially the combination is the PHP and MySQL. Those are likewise any language can be used the relational model. And when we consider the historical perspective of these databases, early 60s, the integrated data store, first general purpose DBMS designed by the Carl's Macam at GE, General Engineers. So form basis for network data model, and Bachmann received Turing Award in 1973 his work in a database area. Early 60s, that is late 60s, IBM developed the information management system MIS system. The 60s till 90s, the IBM has the golden era. So in that era they use this method. So with this MIS system, they form the basis of the hierarchical data model. They introduced the hierarchical data model. Then they introduced this model with the MIS system. American Airlines and IBM jointly developed the subway actually for making airline reservation. They developed the system for airline reservation. You know that the airline reservation is one of the complex system. The airline reservation can be done in different places in the world, because if the flight travels to the fly to the different countries, from the different countries the seats can be booked for the airline. So, and also it must have a real time database. That means when, for an example, when Sri Lanka book is going to book the seat in a Singapore airline, that seat cannot be booked in a different country, because if that seat books by the different country the same seat, what would happen? There may have the passengers may face difficulties to travel, because you know that the limited number of passengers can be traveled, and no passengers allowed to travel exceed the capacity. So likewise, so the American Airlines and IBM jointly developed this airline reservation system, and that is late 60s. And subway is used today in popular the web-based travel services such as Travelocity. Still that system is used. And next one, 70s. So then I explain late 1960s and 70s. 70s, the code. He works IBM St. John's Research Lab, and he proposed the relational data model. He first introduced this relational model to the IBM, and it sparked in the rapid development of several database management systems based on this relational model. Relational model was very famous. When you search this once again, then this code relational model was very famous in that time, and also the code won 1981 Turing Award for this data model. And database system matured as the academic discipline. Also, the benefit of database managed system were widely recognized, and the use of this DBMS for managing the corporate data became the standard practice after introducing this relational model. 1980s actually. 1980s, the relational model consolidated its position as dominant database management system, and database system continued to gain widespread use. So then you can understand how popular this relational model. So the structured query language, the query language developed as a part of IBM system R project, and it now the standard query language. The SQL was standardized in late 80s, and current stand SQL 99 was adopted by the ANSI and ISO. So American National Standard Institute and also the ISO, you know that the those two organizations also adopted this one and standardized since 1980s. So then So the late 80s, 1980s till 90s, considerable research into more powerful query language and richer data model with emphasis on the supporting complex analysis of the data from all parts of an enterprises. So you know that the DBMS2 we have to study the different types of the data, and Microsoft also introduce uh, uh, the relational data model, and several vendors IBM, DB2, Oracle 8, Informix, UDS extended their system with the ability to store new data types such as images, text, and to ask more complex queries. So the different vendors adopted this relational model and they introduced the IBM. Actually, IBM was the main, and DB2, the Oracle. Those are some of them are commercial databases. So if you want to use, you have to purchase the license, especially the Oracle, Informix, like that, and IBM also. Then data warehouse have been developed by many vendors to consolidate data from several databases. So introduce data warehouses and for carrying out specialized analysis. So then you know that in 2000s the cloud computing and data centers evolved, and now it is very famous, and you can get this database facility as a service. Everything you can get as a service, software as a service, hardware also, infrastructure as a service. With that, with the software, you can ask the data centers to provide the SQL or the Oracle database to store your data. Definitely, you will have to pay a rental fee for this data model, and you can get the service from the even the data centers also. And this database management system is a general purpose software system, and it will define, that means specifying the data types. Definitely you will have to define the data types, whether it is the string or the if you want to store the date, you can give the type date as well as integers and doubles. If you want to store the figures with the decimal points, likewise you will have to specify the data type. Structured and contains for the data to be stored in the databases. And constructing, that means the purpose of storing the data itself on some storage medium that is controlled by the database management system. You are going to store the data in the table, relational tables. In order to get that data using some database management system, and sometimes you want to make some calculations, manipulations, and filter and all, and prepare the reports in order to get the decisions from that data set. So and manipulating is the manipulating data includes such functions as querying the database to retrieve specific data. You want to retrieve the specific data. For an example, if you are going to store the student data in the database, and you want to retrieve the students, those who are in faculty of technology, that means you are going to filter the data from a student database. And if you want to get the students who are studying in the second year ICT department, likewise you can filter and you can get. And Also you can manipulate, and if there are some integers, or else for an example, consider the sales database. If you want to if there are many items sold in a certain month, if you want to get the grand total, you can multiply these things and get the summation in order to get the total sales. Likewise, you can easily manipulate the data if the data is stored in a relational tables. And also, when you consider type of the data, numeric and textual data we can find. Numeric and textual data. So the banks, when you consider the banks, simple example is, if you want to withdraw the money from the ATM account, and you are going to insert the bank card and put the PIN number, and you will be asked whether you want to withdraw the money or see the account balance or any other. If you want to withdraw, and you can type the amount that you want to withdraw, then you can easily withdraw the numerical data. And also the textual data also use as there. Banks and multimedia databases also there. Multimedia databases store consider the Amazon.com. They store the multimedia, the images, video clips, likewise. And GIS systems, especially this is very popular nowadays. GIS systems, you can see, if you want to get the location, you can use the Google GIS system to see whether and trace the place. All these images are stored in the GIS system, geographic information systems. And the data storage and retrieval options. What are the data storage and retrieval options? One is the manual processing, the simple, without consider that there is no any DBMS system. So you want to search a certain student. You will have to go one by one until that name is met. Or else, if you want to sort the names of the students in the alphabetical order, and if there are only 10 names or the 20 names, you can do it very easily. But consider that if there are 1,000 or even the 100 names, you will find some difficulties for manual processing, sorting manually. So you may have some human errors. You can't sort those names correctly. So you can understand the difficulty of doing manually. And even in the simple databases, just only have less than 10 records, you can use the manually, but with the increase of the data, it will find some difficulties to manipulate the process the data manually. You know that now the data in the world, when we analyze the data in the world, that is in the zettabyte range. I think the predicted by 2022 or 23, the world data site exceed the 42 zettabytes. 42 zettabytes. I think it will exceed before that. And this will time consuming and does not support large volume of the data manual processing. And file-based processing, these traditional computer files and inadequate for the facility for processing. And database processing, actually, when we consider database processing, is very, very convenient and efficient for processing the data. The file-based processing, consider the data entry and the report. File handling routine and file definitions are there, student system files. Data entry reports, normally consider library system files, and this file has the name, address, telephone number, and, for an example, marks. Student system file, and here in this file, name, address, telephone number, and book load. This is the library at the university student files, student system file and the library system file is the same, name and address also the same, telephone number also the same. What would happen if this person's address or telephone number change? The file-based processing, the same information can be seen in these two places, that is student system file and the library system file. If the student change the telephone or the address, what would happen? All the files must be updated. So here, otherwise, if the student system file is updated, but this has a old data, that is no any consistency of the data. Consistency means they are the up-to-date, not up-to-date data in both places. So the file-based processing has these problems. Data duplication can be found, as well as updated are not there. Here you can see file-based processing and change request, and change the student address and the telephone number, but one place is changed, the library system has not been changed. That means you can find some inconsistency of the data. So inconsistent data can be found in the file-based processing, but this will not happen in the relational model. Limitation of the file-based systems are data inconsistency, duplication of the data, and security also. Only password security can be found. And how do we resolve this problem? Even though these problems are there, but very difficult to handle. So how do we resolve these problems? We can use the database management systems. That means the database the data is stored in one place, that is in the database, and using the DBMS, database management systems, we can use the same data for different purposes. For the student management system used, for an example, academic establishment department use the student management system to manage the students, and library used the same data set for managing for the library purposes. So if the student wants to change his personal information or any, he can request to change only one place. No need to change the two places, because the same data is used by the multiple users. So we can't find such weaknesses if we use the database with the database management system. So as I told you, if the change request is comes to the academics establishment department, he can change the name or the address. So here you can see will change the address. This change can be used even the library also. So advantages of using this database management system: data independence, not the depend with the system. So efficient data access, can access efficiently. So the multiple users can access also, that also must be noted when you consider this one. While the student establishment department is accessing these databases, the same time the library also can access in this data for the different use. But in the file system or network system cannot be done like that. And data integrity and security. The databases can provide the maximum security because data is in one place. And also handling the data, the database administrator can provide some privileges. Only read the someone can allocate assign the security for only read, and the required people only can be given read and update the data. Okay, data administration is very easy, as well as concurrent access. As I told you, multiple accesses. Concurrent mean access at once. Recovery from crashes also. If the database crash, so there are some mechanisms. Normally the databases, the data in the databases regularly get the backups according to the criticality of the data, the importance of the data. For an example, consider the financial institutes, banks. They get the real-time backups. That means when the transaction is done, the same time get the backup also. Because if the database crash, it can be accessed using the backup. So according to the criticality of the data, the backups duration can be decided, whether it wants to get the once in an hour, once in a day, once in a week, likewise. So if the database crash, it can easily recovered using this backup system. And also reduce the application development time. We can reduce the application development time also. Here the data independence, that means the application programs are independent from the data representation and storage details. So the application programmer, database the person who develops the database management system does not know where the data is saved. He knows the path to the server, database server, and the database name, but he does not know in what disk or in what platter the data is physically stored, where the place the data is stored. That is independent from the data representation and storage. So it can easily write the programs. Just he wants to write the commands to access the data. And if he knows the data types and the table names and the attribute names and the database name, then he can use those things to access the data. Then he need not to know how physically data is stored. The structure of the data files is stored in the database management system catalogs, separately from the access program. The catalogs actually, for an example, the file access program may be written in such a way that it can access only student record of the structure. Here is the student record, date of the item, name, starting position and record, length of the character bytes. Name 1 to 30, length is 30. Student number, start, the position is 31 and only have 4 characters. The class, start from the 30 and 31 to 4 characters 34, start from 35, that also has only 4 characters. Major, start from the 39 and only have 4 characters. Likewise, the file access program may be written in such a way that it can access only the student record for the structure. So normally we have to give the type as well as the length while we are designing the database. And program to data independence. 3 file processing systems at some company. Consider this one: orders department, accounts department, and payroll department. So these 3 departments use these database: customer master file, inventory master file, and back order files. So invoicing system use inventory pricing file, customer master file, inventory pricing file, and customer master file. Payroll system use the employee master file. So the different purposes the company use: one is use the order filling system, invoicing system, and payroll system. File descriptions are stored within each application program that access in a given file. So any changes to the file structure requires changes of the file description for all programs that access the file. So consider that when you change employee master file, if new employee recruit to the company, so those information are entered in the employee master file. When the salary is prepared, using the payroll system, that can be used. So, and customer master file, if a new customer is there, or you can add the new customer, there is no any harm for the order filtering system, because the customer master file, in the customer master file, the customer will be entered according to the characteristics of their, if the customer name, address, telephone number, likewise the set of attributes are there, customer can enter according to the customer information must be entered according to the attribute, so that one new tuple can be found in that master file. Inventory master file also same as this one. So you can see whatever the processes are there, if they use the same database and there is no any difference while adding the data to the databases, because the system will not be changed unless if they have the different requirement. So the ordering file system, or else if they have any other new requirement, the system has to be changed. Otherwise they can use only one file system. So then efficient database accesses, when you consider the efficient database accesses, DBMS utilizes sophisticated techniques to store and retrieve the data efficiently, including the support for very large files, index structures, and query optimization. So then those are some advanced topics in the database. Actually, as you are in the first year, second semester students, you need not to understand those techniques. We will explain those techniques gradually when you come to the second and third years. Actually, the database management system is not in finished in the first year. The second and third years also consecutively you have to study. The storage method can be improved without changing the application program. Storage method can be improved. Application program need not to be changed. And data integrity and security. Database management, then when you are going to withdraw the money, you will give the PIN number. But from that PIN number, you can access only your information. No other, you can't access the others' information, as well as others cannot access your information. So the data integrity. That means no one can see and use the others' data. And security means secure the data. For an example, if your account has the amount that the money cannot be withdrawn by someone else, so there we have a high security. So integrity and security is very, very important for the data. So checking account balance against withdrawal, and checking the withdrawal amount against the daily ATM withdrawal limit. So likewise you can find access control govern that data is visible to the different class of users. So the general people cannot be seen, but the authorized people can only view the data when you go to the bank. And also if you give your account number, that only they can see your account balance. Or if you give them the national identity card number, the bank officers see the account balance of your account. Then the administration. Administration actually centralizing the administration of the data shared among the users. Data managed by the professionals and organize data to meet user needs and minimize the redundancy. Minimize the redundancy means the data can be seen only once. If the same data repeated in the different tables, what would happen? You can't find the atomicity or that is, you have to minimize the redundancy. Data can be seen only one place, one data. So fine tuning the storage for efficient retrieval, so that you have to fine tune the data, the efficient renewal, that those are the data administration. And concurrent access and crash recovery. Concurrent access and crash recovery. Concurrent access are scheduled by the database management system. Users can think of the data as being accessed by one user at a time. And also DBMS protects users from the efficient of the system failure. Concurrent access are scheduled by DBMS. Then you know that locking and unlocking systems. The databases also use locking and unlocking system. Consider that this situation. So you are in Colombo and your parents are in different place. For an example, Kandy or Mathura or any other Kurunegala, any other place. So when you went to the bank to withdraw the money from the ATM, the same time your father also went to the bank in his town and going to deposit the money to your account in the same time. What would happen? Same time you are going to withdraw, as well as your father is going to deposit the money. So when you see the one person must give the priority first. So those who come first, even in 1 second, then log the database and provide the facility to the you to withdraw the money. In that time, the father cannot deposit the money. So then when you withdraw the money and finish the transaction, then unlock the database and allow your father to deposit the money. So the concurrent access is controlled by locking and unlocking system. Or else this is the rare case, but it might happen when the transaction is processing. What if there is a sudden power cut, or else the database system is stopped? What happened? You don't know whether you couldn't get the money. When you are going to withdraw, suddenly there is a power cut and stop all the servers, and you couldn't get the money, but you requested to get the money. In such case, you have a doubt whether your transaction is complete, even though without you couldn't get the money, it has deducted from the your account. In such case, there is a mechanism, rollback mechanism. That means it will convert to the previous state of the database. That means once again the user is given the fresh transaction by rollbacking to the previous situation. In such mechanisms can be found in the databases. Then the DBMS protect use from the efficient system failures. So that the one is that rollback mechanism. So then another one is reduced application development time. What is that? The DBMS supports many functions common to applications that access the databases. And high-level interfaces to data also facilitate quick development of the high-level interfaces to data is also facilitate quick development of the applications, and these applications are likely to be more robust than application developed from scratch, because many important tasks are handled by the DBMS instead of being implemented by the application. So the database management system provides some new interfaces and supports for the developers to develop the application. When you develop, you can understand, we will practice in the class by developing even a simple application. When not to use the databases, one is the high initial investment. DBMS is an expensive software package. So application use small amount of data. So consider that small industry having only 10 employees are working, and also they don't have a large customers, only few. In such case, investing for a expensive DBMS is useless. So the application use only the small amount of data. In such case, any other method is very profitable to use. And lack of resources like disk space, memory, etc. to support the database. Nowadays, that also can be solved using the data centers. Unless you have the servers and supporting staff, and you can store the data in data centers or the cloud environment and pay the rental for the data you stored in the data centers there. And single use application also not efficient to use the database system application. Also, overhead of the flexible query, security, concurrent access, and crash recovery is not required. Unless these are required, you better not to use the DBMS. So what do we store in a database? When you consider collection of data in a central to some enterprises, the collection of data central to some enterprises, essential to operation of enterprises, as well as historical data can be guide enterprise strategy or interest of the other enterprises. So if you need to buy the cupboard to store your valuables, which model do you like to select? You want to store your jewelries and also the valuables in a cupboard. What do you use? It is important to select the cupboard by considering what we are going to store. So just you have to store only your books. You need not to have the cupboard with the doors. You can use the cupboard like in the middle one, because it is very easy to select the books. You can store it to see the names. And if you have to store your valuables and jewelries, wristwatches you have and other things, you better to use the final one, because you can see that there is a door with a lock, and also inside the cupboard also you can find some lockers. So according to the database data that you are going to store, you can select the bases. For an example, the banks and the financial institutes are not using the MySQL database. They always go to the commercial versions and highly sophisticated databases like the Oracle and other things. So another thing is, the commercial databases provide more facility than the open source databases, so that most of the multinational companies and the companies that handle the what we call the critical data always use the commercial databases. So today I want to discuss the historical perspective of the databases and the usage